Hello, ngHouston. Okay, so tonight we're going to do something a little bit different, and this is going to be fun. We have Abe, and he's going to talk about Unity, the 3D game platform, which is going to be cool. And we have a panel full of teenagers. So we are all beginners, and we're going to learn this from the very beginning. But first, let's say hello real quick to our panel. Nicholas, you want to say hello?
Hey, I'm Nicholas. I'm 13 years old, and I don't really have that much experience in programming.
That's perfect. Alex is actually my long-lost son in joining us from New York. You want to say hi, Alex?
Hello. I'm Alex. I focus a lot more on the art stuff, so I'm excited to see if this will let me like build games more as an art and less like learning a new language.
Awesome. Awesome. All right, you guys know Samantha. Samantha, say hello.
Hi, I'm Sam, and I'm
She's
Sam.
a troublemaker. She's here to make trouble. All right, and that brings us to our guest star, Abe Haskins. Say hi, Abe.
Hello, my name is Abe Haskins. I'm a developer programs engineer on the Firebase team at Google, specializing in our integrations with Unity and other game engines. And I'm gonna talk about some games. Is there anything else we need to talk about, Bonnie?
I think we were talking about this before we were live. We were talking about hardware requirements. I think that's a good place to start. So you want to talk for a minute about like what kind of computer you need? Obviously you can't run it on a tablet, but I was curious if you need like, because I know for some of the audio stuff or some game mechanics, I always thought you would need like a really screaming fast machine, but it seems like that might not be the case. So if you talk about that and then just jump on in and show us.
Yeah, absolutely. Let me actually start a little earlier than that. So just in general, Unity is a free piece of software that you can go download. So before we're even talking about hardware, just know you can go download this for free. There are paid versions of it that allow you to do things like sell your game over a bunch of revenue or things like that. But if you want to just dive in and get started with it, it's completely free. And you can even release free games or paid games that don't make that much money without paying anything. In terms of hardware, Unity is not super intensive. It is a large program. I think installed it's maybe 5 gigabytes or something. And I don't know what those 5 gigabytes are used for because it doesn't look like that much software, but it is quite large. And if you're building out like an Android game or an iOS game, that's even more space in the tooling specific for those platforms. So your bigger requirement is going to be like a fairly large amount of free hard drive space, not graphics and graphics power or anything like that. Those help, but I run it on my like old Yoga 2 laptop. I think it's like 4 years old and it runs fine. Admittedly, I do mostly like 2D stuff, but the 3D stuff works just fine too. But obviously, if you're building something bigger and more grandiose, it's going to take more power to process that, but it's, scaling with it. If you're building a game that big, maybe you should get a bigger computer anyway. But in general, it's pretty easy on the system. So we can kind of dive in. My goal with this panel and our conversation today is to kind of just play around in Unity and figure out what we can do with it. I'm going to look towards my amazing panel here to kind of guide what we want to make. I have a little project that we can start with, but in terms of where we go with what we build, it'll be largely up to you guys, and I'll be asking questions and stuff throughout to guide this. Like I said, I have Unity installed. I have it all set up. If you wanted to go download it right now to like play along, I probably wouldn't recommend it because it is very, very large to download, and it will make the call all jittery. But you could if you want. But I wouldn't try to follow along with what we're about to do. I'm not going to present it in a way where I'm leaving code up long enough for you to like copy and paste it or anything like that. We'll just be playing with it and going back and forth. So let me start off by closing Twitter because somebody demanded I was retweeting things before this. Now sharing my screen, whoosh, and hopping over to Unity. Before I even do this though, let's go to new project. So when you first load up Unity, you're going to see a new project window like this. Can everyone see what I'm talking about?
Yep.
Yep.
Awesome, awesome. So this window is just what type of project do you want to make? Like I said, I'm particularly fond of 2D games. Unity is largely known as a 3D game engine, but they put a lot of effort into letting you build 2D games as well. So whatever you want to build, you have options for. And this little button here that says, do I want to make a 3D project or a 2D project, that actually doesn't change It just changes a little bit about how the editor looks. So it's either tailored for making 3D games and working in a 3D space, or a 2D game working in a 2D space. So I'll just make like a brand new project, and we'll call it, ngHouston. Name doesn't matter. We'll call it a 3D game. I think most of my demo today will be in 2D because it's a little easier to understand, but I'll show you the gist of the 3D environment to get started. Hit create project, give it a while. Watch that happen again. Here, I'll close this down so you don't have to watch that. This is a very common thing to see in Unity, is that progress bar just taking forever. And so I know we were talking a little bit beforehand. Everyone in the panel has gotten this far except for Alex, I believe, who's more interested in the art side. That's right. You've all seen something like this, your scene view and your big game view and everything like that. Is that right?
Mm-hmm. Yep.
Awesome.
Abe,
And so,
will you?
yep.
Oh, sorry.
No,
Will you
go for
actually
it.
go over what a scene is? Because I use them, but it never explained, the tutorial I watched never explained what a scene was.
Yep. So a scene is like the container of your game. So if you're building a game, it can either be individual levels, it can be your entire game can live in a single scene. It's basically just a container for everything you put together that shows up in a grouping. This could be considered like a class file type thing. It's not quite that because it also contains assets and art and things, so it's not just code, but it's a big grouping of everything that's going on in one context. It's really not that important. For a very long time, you can get away with only having one scene, and you don't really need to understand any mechanics about scenes or how like scenes interact. Just know if you have a scene, it's your playground, it's your sandbox to go drop stuff in and program and make a game. It's, there's advanced concepts beyond that, but they're not important if you're just building something relatively small.
Awesome.
That answer cool?
Yes,
So-
thank you.
Yep.
Actually, I have a question.
Go for
If
it.
you wanted to get like different scenes, could you, and where would you find them?
Yep. So when I made this new project, over here in the hierarchy, and I will say my view here, my editor, is going to look slightly different than yours. I have this set up to work on my laptop screen, right? And I have my game window kind of resized to be more like a mobile device screen. But look at the tab names if you actually care. So like this is a game tab, this is a scene tab. You'll have all of those. They just might be in a slightly different orientation. But in terms of scenes, if you look at the hierarchy view over here on the left, this top level thing with that Unity icon that says untitled, that is our scene. So anything we put in is in this scene. So if we just hit Control S right now, it'll say, what do we want to save our scene as? And I can call this like main or something like that. Now in our assets, we have a main scene. But if I wanted to, we'll just add a game object, add like a cube into this. So we have this cube showing up. If I wanted to make a completely unrelated scene, I could save this and go to File, New Scene. And as you can see, cleared that out because we're now in a different scene, and we can save this and say this is like second scene. And this shows up down in our asset panel below. So we now have that main scene that has a cube in it that we can interact with and do whatever. And if we double click on second, we have a second scene that is for whatever is secondary. So they work just like anything else you'll bring into your project, like scripts or images or anything like that. It's all going to show up in this assets pane below. And so you can think of them just as another object that you're dealing with or making more of or not. Like I said, in general, you're only ever going to really need one. There are situations, but for the vast majority of things, don't say that, you'll only ever need your one main scene. That make sense?
Yeah, thanks.
It seems like that, I've played a few video games in my life, and it seems like a lot of times they'll change scenes when you go from one level, like when you finish first level and you start on level 2, if you have more than one level on your game, then that would be a good place for a new scene, huh?
Yeah, it absolutely could be. And there's also situations where it may not be. And I wish there was a more clean answer to here is when you should make a new scene. But it really depends on your games. Depending on how your game is rigged up and controlled, it might be easier to just destroy a scene and make up a new one or have multiple scenes per level. it's really up to you and how it makes sense for you, which is, you know, common in programming. It's kind of what makes the most sense in your situation. But yeah, level by level is definitely a way people do it. I've written entire games that have only one main scene and then, you know, one additional scene that is like the menus and things like that. So there's one gameplay scene, one menu scene, one setting scene, so that anything in like the main menu is not related at all to the gameplay. That can be completely separate, put somewhere else, and then we load the scenes as appropriate. So there's lots of different options. Absolutely, go for it.
So it sounds, based on the way you're explaining it, like it's largely a personal thing. If you want to make each individual room a different scene for smaller games, or entire cities one scene, it's whatever you want to do, right? Or if you want to link cities together all in one big scene, that would be a lot of work, but you could do it, as opposed to just making each one an individual.
Yep. And there's even more cool concepts where you could, for example, build an entire building as a single scene and then bring that scene in to another scene. So you could have a city scene that was composed of 20 different building scenes, so that when you're dealing with it in the editor, you can only be interacting with the one building, but in your actual game, they all get assembled and put together. I don't want to dive too far into scenes because they're really just not that important. If you're doing something like that, there's lots of other options. But yeah, it's pretty arbitrary how you want to split it up. It's just whatever makes sense for you. And a thing like a cityscape is a great example of when you'd probably want multiple scenes or multiple different size scenes. Or you could even do stuff like the actual overview of the city is a lower resolution, like simpler art version of a scene. And once they go into a building, you switch to a different scene that is like the interior of the building or something like that. You have a lot of control over loading and unloading scenes and doing stuff like that. But like I said, for the majority of things, you'll only really want one scene and then maybe a couple others for menus or, you know, loading screens and things like that. Cool.
Yeah, this is pretty cool.
Cool. Awesome. So I already added this cube. I did that pretty fast. So I'm going to show again how I did that, which was, like I said, you have this hierarchy view. Hierarchy view is where everything in your scene lives. Down here in your asset pane under project, that's where all of your assets live. So the difference is that if you have an image of a cat, if that is like something that shows up in your game, that'll be down here in the assets pane. But if you have that image of a cat put onto ground or on the side of this cube, for example, it'll be in the hierarchy as part of the cube. So it's kind of like, here are all the things I have that I can possibly work with down in my asset pane. And then here's all the instances of that are actually in the scene up in my hierarchy view. We can add a bunch of different stuff to that hierarchy. We can add things that you can see like a cube. We can add things that just control and orchestrate the game. You have a lot of different options. I'm mostly going to be talking about things you can see and kind of touch and feel in quotes, but there's lots of different stuff you can play with. If I want to add something new to that hierarchy view, I can go up, and I'm on a Linux machine. It'll be a little bit different on Mac or Windows, but you go up to that top menu or wherever it is and hit game object, and then you get all the different stuff you can add to your scene. You can see 3D objects like cubes, and spheres, basic, you know, geometric shapes. 2D objects if you're doing a 2D game, which is just a sprite, so that's just one image drawn to the screen. We can add lights for doing different lighting effects. By default, we have this light right here that's automatically put into the scene, but we could delete that light like that, and you see how everything gets dark? That's because there's no light, there's no lamp in my scene. So we could control that, add different lighting effects, things like that. We have audio things. So if you want something to be making a noise, video, if you want like video playing in your game, UIs for overhead displays, so like health bars and things like that. You don't want in the actual scene, those go in UIs. Particle systems, which are really fun, and I'll show off a little bit later. And you can add other cameras. One of the core concepts of Unity that's important to understand is that the view of this world you're creating, of my cube and my lights, this is all happening through a camera. And we can see that camera automatically added to my hierarchy view over on the left. And when I click on it over in my scene view, it shows this little camera icon, and it gives me an idea of the perspective of the camera. So if I move by clicking this top little perspective cube up here, I can see, all right, my camera sits here and it views this rectangular shape, which matches the shape of my game view. And I can see how the perspective extends over space and time and things like that. So we can see how we're seeing it. Yep.
Are you zooming it or drag it? How do you make that camera move? You just like zoomed it or something. Was that like a mouse wheel thing?
So I'm clicking this little control cube up in the top right. So if you
then
click,
it zoomed, or it does that automatically.
Oh, this zoom, that's me scrolling. Sorry.
Okay, with your mouse wheel.
Yep. Yeah, and we can also grab and yeah, it's a mouse wheel.
Gotcha.
And we can also grab and move to like rotate, kind of like a head looking around. So I'm right clicking and dragging right now. I was talking to Sam before we started that it's kind of confusing to move around in this environment. You can end up moving in a wrong direction or getting yourself in a perspective that you don't expect. So that can be a little tricky, but you can always go back to this cube up here and click on this and click, like fiddle with these until you get a nice, side view or something like that, or top view, bottom view, whatever, and go from there and then move again. So that can always reset you back to a not lost perspective. So that's the general idea with this camera view. Is this camera is looking forward at something, it's looking at whatever we put in the scene, and that could be shapes, it could be objects, it could be players or pictures or whatever. Just the camera is going to see it and it can render. There are situations where you might want multiple cameras in a scene, like if you were building a cutscene that showed someone walking into a room, but then after that it goes to a first-person perspective on that character. You might want to do multiple cameras, but again, that's a pretty advanced topic that you really don't need for a lot of things. So I want to get into actually doing something with this. We've been stuck down in just like talking about setting up scenes and things like that for a little bit, and I want to actually build something that we can see and we can play with. Because right now, if we go to these controls on the top, you can see we have 3 of them: play, pause, and next. If we hit that play button, that'll turn on our game. And nothing will change. Absolutely nothing happens because we haven't set up anything to happen in this game. It shows our cube still, but it hasn't changed anything. If we want something to actually happen when we play the game, I'm going to pick up this cube that's I've now selected in the hierarchy, and I'll go to the top left and switch to the item dragging handle, which is the second one to the left, and I'll lift this up so it's a little higher. So now it's at the top of our camera. And then I'm going to make it fall. I want gravity and I want physics to apply to this. Because this sandbox we have is full of physics. It works a lot like the real world. If you add shapes together, they can knock off each other and move around and roll off the table and things like that. But we have to make sure that the game engine knows that we want physics to happen on these objects. So I'll do that by clicking on the cube and then going over here to the inspector. And the inspector is a really core concept in Unity. This is where any game object in your scene is going to have all its properties defined. So you can see by creating this cube, it added a bunch of properties by default. It has a transform, which means this cube has a position. So if I change this to 0, 0, it moves the position of the cube. It has a mesh filter, which isn't that important to understand. And it has a box collider and a mesh renderer. The mesh renderer is what makes us actually see the cube. This is what's saying, show me a white cube. And if I hit this checkbox, we can't see the cube anymore. It's still there. It's still in the scene, but nothing is actually rendering it, so we can't see it. If we put the mesh renderer back on, cube shows back up. We can do a bunch of different stuff here, like changing what material is rendering to the cube, making it different colors, things like that. But we won't be doing much of that right now. However, the renderer is actually what takes care of the visual part of it. The box collider, which is up here, is the most important part in terms of making this interact in your game. The box collider says, this is a cube. It has the physics properties of a cube. So it has 6 sides, and it is shaped like a cube. When I click on this, we can actually go and we can see, it's hard to see because I also have it selected, but there's very faint green lines along the edge of the cube. That's showing me where that box collider exists. So in this case, it exactly matches the same size as the renderer and as the cube itself. So if I drop this, the physics will happen exactly as you would expect. However, that doesn't have to be the case. I can go into the size in the box collider, and I can make that bigger. When that happens, this cube now has physical properties bigger than what you see. To illustrate this, let's actually make it collide with something. I'm going to add another object into our scene. I'll add in 3D object. We'll add another cube, and we'll make sure it's directly below this cube. So this cube has a position of 0, 5, 0. So we'll set this one to 0, 5, 0. And then we'll grab the screen handle and just drag it down. So now this cube is directly below the top cube. And then to center this all, I'll move my camera up a little bit so we can now see our two cubes really, really well. Again, now, if we hit play, nothing happens because we haven't actually told the game, hey, do gravity, do anything. So we need to go to that top cube, the one that we want to fall onto the bottom cube. We hit add a component, and we'll add what's called a rigid body. And a rigid body just says, hey, this is something that's going to be moving, it's going to be interacting, it's something that you need to think about as part of the world, as part of like a physical item. So just by adding that rigid body, we're telling Unity, do physics, make this actually move. And if we hit play now, that cube will fall, and it falls perfectly on our other cube. Now that's fine, that's plenty interesting. But if we move it over just a little bit, we can now see some more interesting physics as it falls and falls away. So the physical properties of these cubes interacting are all taken care of by the engine. Obviously, I didn't write any code to do this, but there's a really powerful bunch of options for defining how things interact. So for example, right now, I drop this, and it falls perfectly. Notice how the size of this cube makes it sit perfectly on top of the other cube. But if we go back and we modify the size of that collider, we set it to 222, so it's now twice the size of the cube. You can see we have that green outline showing around that shows where the physical boundaries of this object are. And if we hit play now, it comes to sit on top of that cube with that resting space because the physical properties of that cube are bigger than the properties of the actual thing we're showing. So this is pretty crazy because in the real world, obviously, the size of things are related to what we see, like they're generally the same, but you have a lot of flexibility here. And one of the great things about Unity is that we can now tweak this while the game's running. So if we say, instead of making it twice as large, why don't we make it half as large? There you go. And you can see now the cube falls inside of the other cube, and it comes to rest right in the middle of the cube, which is really crazy. One of the things about Unity is that I just edited this while the scene was running. So if right now I pick this up, I drop it, the same physics apply. As soon as I hit this play button, so as soon as I exit the actual game, it's going to reset any changes I made during the scene. So these size properties, 0505, if I hit stop playing, those get reset to 222, which is what it was when I was in the scene, or when I was in the editor. So that allows you to easily know, or easily reset after you've played around with something in the game. So you can go and make changes and tweak things, and then hit play, exit out, and it'll just reset back. So anything you did there, it'll still be, it won't impact your actual development of the game. How's that feel? Did that make sense? Do we understand how physics are kind of interacting and what I did to make that happen?
Yeah, that is really cool.
That's all right. Everyone else making sense so far?
Yeah.
Yeah.
So far, yeah.
I mean, it makes sense to me how it's working in the game, but I can't figure out why you would change the physical size just if you want to do like weird stuff in your game.
So I'll show a better example of why we'd want fine-grained control of that later. The short answer is that games cheat all the time. Like games are just liars. Every cool thing about a game is like some weird hack that someone did. So a lot of times, in order to make things look good and in order to make it look like your game is like a AAA really nice game, you have to fudge things. So a player will run into the wall more than you would think they would, or a player will sit lower, like into the grass, than they really realistically would, because it makes things look better and feel better. So having really good control over these allow you to make something that looks like how we expect a game to look. Because in general, we don't actually expect video games to match physics in reality. It's a pretty fine line, but we'll see some more advanced collider stuff once we get into the second part of this demo, into the 2D stuff where we can really fiddle around with colliders. One last concept I want to talk about in regards to physics, though, is the idea of a material. So in the real world, these two cubes are probably made out of something pretty hard, because if you notice when I hit play, they just slam together. They're probably made of like rock or wood or something where there's no bounce, there's nothing interesting like that. But in our game, what if we want to do something more interesting? What if we want to make a rubber ball or something more liquid or something that isn't firm, like a soft cushion or whatever? We need more control. Having just a cube that just plops down isn't what we want. So I'm going to change this a little bit. I'm going to get rid of our top cube, and I'm going to add in a game object, 3D object. This time, I think I'm going to do a cylinder. A cylinder sounds pretty fun. We'll set this back to a similar position as our cube. And then we're actually going to rotate it a little bit. So we can go over here to the top left and click on this third icon, which is our rotation handle. You see we get this interesting circle cylinder, sphere of rotation angles. And if we grab one of these thin colored lines, we'll be able to rotate the object. So if I grab the blue line, it rotates like this. If I grab the red line, it rotates like this. And green line, it rotates like this, which we can't see because it's a perfectly symmetrical cylinder. But that's how you rotate something. So I'll put this up here. And if we hit play now, oops, it doesn't have a rigid body. Of course, it has a rigid body. So now it actually has physics. And we fall, and it just kind of plops off. That's not very interesting. Now we want to modify that.
Can you go back 1 second? First of all, that's very cool, and I want to see the bouncing because I know you're going to do that, and I'm excited for that. But you added that rigid body really quick, and I missed it.
So that anytime I go to add a component, if I say I'm going to add a rigid body, add a collider, it's all by clicking on the object I want to interact with, and assuming that menu actually goes away, clicking on the object, hitting this add component. And then in here, you can click through these and pick whichever one you want. Like there's a ton of different things in here. But I knew I wanted rigid body, so I typed ridge. And we have the two options, rigid body for 3D physics and rigid body 2D for 2D physics. So I just hit that and added that. That was a good call. That's something you do so often. You add so many rigid bodies to so many things in the world of Unity that it's very, very quick to do. But yeah, anytime.
And tell us one more time, what is a rigid body? Is that the like?
It is.
Go ahead.
Yeah, so a collider says where the physical properties of something are. A rigid body says this thing actually interacts with the world in terms of movement, gravity, things like that. Gotcha. So one is saying, here's the edge, and one is saying, all right, now that edge actually interacts with the world in some way.
Gotcha. So you pretty much always need a rigid body.
Yep, unless it's something that doesn't move. So for example, I have this bottom cube, right? I don't want a rigid body on that. Because if I put a rigid body on my bottom cube, we will see if I have one on my bottom cube and on my cylinder, it's kind of going to break my demo because they just both go away.
Then they both move.
Yep, exactly. So it's really important that I not have a rigid body on this bottom cube because that's acting as the ground. So if we remove the rigid body, now it follows.
I think Alex has a question too.
Go for it.
Alex, I don't think he can see you, so jump in if you have a question.
Right. I think giving something a rigid body does exactly what it says it does. Like it gives it a body for gravity to pull on, for other things to bounce off of.
Yep.
And also, I really like the fact that you gave it like the axes. Like there's individual lines for you to pull on. So if you want to turn something across one point of rotation, you don't have to worry about anything else. You'll get dust at that one angle, and that's pretty cool.
Yeah, there's always options in Unity to like go and drag and do things very graphically. Or if you want really fine grain control, anything related to the position is going to be under the transform part of the object. So if I wanted to, I could go in here and set a rotation of exactly 45 degrees or something like that. So you always have that control. But yeah, the tooling for just moving things and rotating them is really, really nice.
This is fun. This is so cool. We haven't even hardly gotten into too much yet, but I'm already like, I'm going to lose all my Angular developers. They're going to jump over to the video game world, and it's going to be your fault.
I have another question.
Go for it.
It's not like a huge crucial thing, just to kind of see how this works. If you had two cubes, like both at 45-degree angles where the edge is up and you drop them on top of each other, would one like roll off? Would it automatically put in that asymmetrical weight, or would they just sit perfectly and assume that it's all equal?
Why
Like
don't
on
we
the corner?
If you had two ones hit perfectly on the corner, would they balance?
Yeah,
That's a very good question.
That's a great question. I think I know the answer, but I don't want to be wrong. So let's try this. I'm going to do a really cool thing. You notice how I hit this checkbox here before to like turn off the mesh render of an object? If I click this checkbox up by the name of the object, it'll just turn off that object completely. So it's no longer in the scene. And you'll notice if I look at my hierarchy view, it is now completely gone. It's not completely gone. It's this lighter or darker gray. So that means it's disabled. It won't interact. No code on that will run. It's just in there as, like I can turn it back on later. So if we leave that cube in, we go to my cylinder, we hit that checkbox. Now that cylinder is gone. It won't interact with anything. And we can try this cube thing. So let's turn this exactly 45 degrees. Whoops, nope, wrong angle. Exactly 45 degrees. And then we can just hit Control-C, Control-V in the hierarchy to make an identical cube at an identical angle. Go to our object moving. And you'll see this is kind of weird now because these controls are oriented to the cube. So I can't just pull it up straight because that would make me, I have to like go like this, but I don't want to do that. So I'm going to go over to the transform. And I'll say, nope, wrong axis. I can never remember which one of these moves in what direction. I can never do it. Nope. All right, so it must be that one. All right, yeah. So those are now perfectly on top of each other. And I'm gonna put this one on top. So we'll do -2, 4. There you go. All right. So now these are perfectly on top of each other. And if what happens, we'll see where this goes. And we don't have a rigid body. Anytime you hit play and it doesn't, not what you expect happens, is because you forgot to put a body on it.
I'm kind of excited for this because I think either way it's. Oh,
there you go.
Okay, so that means it's automatically going to put in all the little imperfections and stuff that'll make everything fit, which is cool. That's a much more intuitive way to do everything.
Yep. And one of the cool things is this is getting into a more complex topic, but you'll see every single time I do this, it always, always, always falls to the left. It's never going to fall to the right. And the reason for that isn't anything specific about like the setup or anything. It is due to the fact that the way Unity runs its physics, they are deterministic, which means if I hit play, it'll do the exact same thing. So
I think it's amazing how, I've been around for a while, right? And to do something like this in a video game years ago was so much programming and, keyframes and all that. And the fact that it's all done for you is it's like you could just start so far forward than what you used to have to learn to get to this point. This is so cool. And it's free.
It is free. It is absolutely free to go play with.
Hey, Abe.
Yep.
Those 5 buttons at the top, again, you never like 1 or 2 of them. Would you mind showing what they all mean?
Okay, so these controls up in the top left, these are all of your, so I don't know why they're so far up in the left. They really should be tied to the scene view because these all interact with how you deal with your scene. So if I have this big hand, that'll let me drag my scene around to look at different angles. So it's just kind of like moving the scene camera. It's not moving the game camera, it's just moving what we see in the scene. If we hit the second one, that'll allow us to move the position of our object.
Whichever one's selected in the hierarchy.
Yep. Whichever object you pick. So yeah, you'll see you get the little handles on whichever one you're dragging. The next one, the turny one, has to do with rotation, just like we were showing before. This gives you the handles for rotating an object.
That's my favorite.
This one gives you your scaling controls. So we can make a crazy sized cube if we want. And one of the cool things about scaling objects in Unity, oh, that's fun. I want to see what happens if we hit play on this. It slides down. Boop, 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 boop.
That's cool.
That's fine. So you noticed when I did that, it still kept this box collider as the exact right size for this cube. So even though I was resizing it and playing with it, Unity said, you know what, he's not trying to change, he's not trying to change how the collider actually works. He just wants it to be bigger. And so when I did that resizing, it kept the box collider to the right size. And we can still go in here and make it twice as big or whatever if we wanted to. But Unity's smart enough to say, no, if he resized the whole cube, he probably wants all the physical properties of the cube to go with it.
Hey, Abe, so back to what Alex was saying, if you did want the cubes to balance on each other, how would you do that?
Okay, let me cover the last control here, and then I will get to that.
Oh, yeah, sorry.
This last control is the box collider editor. So if you wanted this the collider editor, so if you wanted this collider to be something completely different, you hit this, it gives you these little tiny blue handles, and then I can grab those and I can deform if I can click it. Okay, I might not be able to click it easily, but it lets you deform the collider or whatever the rectangle. Yeah, I don't think I'm gonna be able to click these easily. It lets you deform the collider. Anyway, yeah, so if you wanted those to balance perfectly, that's actually a pretty interesting question. And the answer is there's not a super easy way to do it. And that's because there's two ways to make a game. Way one is you start the way Bonnie was talking, which is the traditional way where you say, I have absolutely nothing and I'm going to program everything from scratch. So if I want something to happen, like two cubes to balance on each other, I have like super fine-grained control over that. The other way, that is the Unity way, is saying, I'm going to give you a physics environment that I think you want, and I'm going to do everything I possibly can to like make it a realistic environment for you to then add like constriction on so that your game makes sense in this environment. So something like two cubes balancing perfectly on top of each other doesn't really happen in reality. So it wouldn't make sense for Unity to be able to mimic that out of the box. However, we can start tweaking the physics engine just a little bit to be able to control this. And a lot of things, if you ask, like, how could I make the Unity physics engine do this? It would probably be pretty difficult. And while I was talking, I realized there is actually a relatively easy way to do this that I can show. But a lot of times you'll find that trying to make this cube is still falling, by the way. It has been falling for the entire time we're talking. So that cube is really far down there and I can't see it. But I should have unhit play. So in general, like, it's hard to make a physics engine not act like physics. That's the point of it. But we can do a few things. So let me reset my gigantic sliding block to 111. So it's now directly below it, and I just reset the scale here by typing in 111. And if we hit play, it'll fall, and it'll fall to the left just like it did before, because like I said, it'll happen the same exact way every time. And we can go to that top cube, and we can go look at our rigid body, which is, again, like what allows it to interact with the world. And we have a couple of options here. We can set things like the mass of the object. So if we set the mass really high, it would have more inertia and it would have more force when it runs into another object. We can set the drag, so like what is the resistance to this thing moving, angular drag, et cetera, et cetera. We can turn off gravity if we wanted, which just makes gravity not happen for this object. So the rigid body is still there, but it doesn't have gravity. There's a bunch of options here. Some are more complicated than others. But the important one we care about for making these balance are these constraints here. And these constraints allow us to say, hey, act in a completely real physical way, except don't do it for this property. And there's only 6 things that the physics will impact. It's the position, x, y, and z coordinates, or the rotation, x, y, and z coordinates. So if we don't want this cube to ever slide off, we can freeze all of the rotation of it. So now we're saying, do whatever you want position-wise, fall, go wherever you're going to go, but never, ever rotate. And if it never, ever rotates, it should stay perfectly balanced, because there aren't those little things Alex was talking about that are like the randomness. We're just saying don't never, never rotate. So if we hit play now, it falls, and it falls perfectly balancing on the other cube. Yeah.
I have a question.
Yes.
Why does it always fall to the left?
So it falls to the.
That's a good question.
Yeah, it's a great question, and it's a question I don't really have an answer for. And I think if we fiddled around with this enough, we could unfreeze this, and you'd find that if we like put this cube slightly higher, or like, put this at a y of like 8 and a y of 7, and we kept changing heights, eventually it would fall the other direction. It's just because of the way like the engine decides that when you hit, there are these little bits of physical inertia, little bits of movement that make it lean left right now. And because the game plays out in the exact same way, exactly the same in every little force, every single time, it always falls left. That could have been it always fell right. It's kind of up to the engine to put all those little bits of physics in there and make it fall a direction. So I don't really know why it goes left, but I do know that it'll always go left if I run the same code. If I lift up the object, or I change the mass or the inertia or the drag, all of those might make it fall in a different way, but it'll always fall the exact same way when I hit the play button.
So the reason you said it would always fall to the left is because it fell to the left the first time.
Yep, that's exactly it.
Gotcha.
Alex, did you have something to?
Yeah, I was actually going to say, I think that balancing stuff on top of each other, it puts in the randomness to protect you from looking like you don't know what you're doing. Like say you build a shooting game and it discharges little shells after you fire. If it didn't have this, you'd look over after you're done shooting and every little bullet casing that you fired would be in a perfect tower.
Yep, yeah, things like that, yep. They absolutely do. And that's what most people want. And that's why in the physics engine, it just kind of acts realistic. Like if something happens, it has that randomness, it has that whatever that makes it, look random to a user, but be predictable to a developer trying to build a game.
Yeah, so it assigns it enough randomness to where you're not going to get weird, illogical things like that, but it's a consistent randomness. So if it decides to fall to the left, it will keep falling to the left.
Yep, exactly. And this is a really interesting concept. It's actually one of my favorite things about computers in general, which is that they can't make random numbers. So your computer might look like it can do something random, but it actually can't. It's using what's called the seed to say, I'm going to go and like pick a big number and then look at that number and make a random movement or change based off of this seed. And that's what Unity is doing. It always plays out the same way, and it always has the same seed when it goes to play the game. So all of those randomness, even though it seems random and it is functionally random, since that seed, that initial state is always the same, it's always going to play out in the same way. But once you go into the game and players start doing things, that'll change and the randomness will change and it'll look really, really random. But that's a whole other discussion. But yeah, randomness in games and in computers in general is super, super interesting, but different discussion, much less interesting than cubes falling on each other.
I think it's a good thing though that it is that consistent, because then if you want to get a lot of precision in, you know that that if you fine tune it enough, you will get the same results every time. You're not going to have it accidentally bounce off a wall in one running when it didn't before.
Yep.
And I also really like that it gives you the opportunity to freeze things like that. Like if you want everything to be accurate, but not do a certain thing, you have the control to stop it from doing that. And that's really cool.
Yeah, I actually have something cool I can show besides this. So we can, I'll show it later. I have a more complete demo I want to show you guys. That's really neat. But yeah, knowing that your physics will always happen in the exact same way. Yeah, it allows you to set it up perfectly. So if I put this force on this object at this point, it'll always do the exact same thing. It's super, super helpful. Okay, so any other questions related to cubes falling?
I'm about ready for the. I think you were about to bounce, and then we hijacked you with
I was about to bounce, which is okay. So now that remember we have this cube set up, so it'll never ever fall, right? It'll just balance perfectly, except I turned off those buttons. So let me freeze the rotation of our cube. Now it'll never ever fall. It just bounces. This is like a material that's like stone or wood or something that doesn't really bounce. But what if we wanted this cube to be made of something else? What if it is a rubber cube? Or like Alex was talking about, what if it's a shell casing from a bullet from a gun? That's going to bounce in a unique way. It's not going to just plop down to the ground. Like those things bounce. How do we handle that? And the answer is we can create what's called a physics material in Unity. So if we go down here into our assets pane, we can right click or command click and go to create and look for not material, not physics material 2D, but physics material. And we'll call this rubber. So this material is not something we can put into the scene. I can't I can't drag this into the scene. I can't put it in the hierarchy. This is just like a set of properties that that control how an object relates to all other physical properties. So if I touch this up in my inspector, you'll see it now says, all right, you have a rubber and you have a bunch of different options. Friction, bounciness, friction combined, like other very fine-grained physical settings that I don't really care about. All I care about is bouncing. So if we set this bounciness, this is going to be like telling you that it's rubber. So if we set a bounciness of like 0.4, so it's out of 1, so it's 0 to 1 bounciness, 1 being there's no loss of energy when it bounces. So it hits the ground and it bounces up exactly as high as it went, or as high as it came from. It'll never stop bouncing. To 0.1 is 10% of the initial height of its falling. So if we hit it 0.4, that should bounce up to about like here. Nope. Sorry, I didn't actually put it on the cube. This is a good rule. Go to your cube, drag your rubber, and put it on the physical property. Yep.
Do you have the option of setting it above 1 if you just want to mess with the world?
Setting it above 1.
If you want it to like bounce higher and higher each time. Like if somebody's...
That's a good question. We may be able to set it to a above 1 value, which, okay, it doesn't let me here, but we could do that. And the trick to that would be applying a force to it. Like every time it hits the cube, like put a little burst of air beneath it that shoots it back up higher. And you'll find this in doing game development is that a lot of times it's really like setting up like a little mechanical thing that makes it look how you want. So like in that case, yeah, we might be able to set the bounciness higher than 1 to get like 110% bounce. But a lot of times it's just like, no, you know what I really need is like a stick that pushes it back up and that gives it the right type of bounce. And because it happens the same way, you can be confident that it's going to keep on bouncing forever. But it does not appear we can set a bounciness above 1, so we can't do that, sadly. But yeah, so I can go to a cube. I'll go to my top cube, cube 2, and under the box collider, we have a material option. If you click the little tiny circle here, it'll pop up this dialog that says select a physics material. And this, if you're on the assets tab, you'll see all the materials you've created. So none is an option, so it just defaults to that like hard rock or wood, or rubber, which is what we just created. So we'll select rubber. And now if we hit play, let's see what happens. Oh, it bounced. It bounced just a little bit. And then it got stuck. So that's super interesting. So can anyone guess why my cube is not sliding off of the other cube? How did it manage to bounce and then stop?
Friction when you added bounce.
That's exactly it. The default material had less friction than my rubber that I just made. So in here, we have these friction properties. So if we wanted that to slide off, we'd need to act like something else. So let's unpause this and let's go to look at our friction. I'm not sure what static versus dynamic friction is going to impact. So I'm just going to set these both really low. So like 10% friction. Let's see how that works.
I actually just happened to remember that from physics. Static friction is how hard it is to start moving, and dynamic friction is how hard it is to stop, unless I'm mistaken.
That's a smart stuff that I have long forgotten from school.
He might be a beginner on Unity, but he's real good with physics.
That's very helpful. So there you go. That's what the difference is. And if we set those both really low, like I said, we'll see a different behavior. And now it bounces once and slides right off, exactly like we'd expect. And this bounciness honestly still feels pretty not bouncy. So let's see if we can set a higher bounce. Okay, there's a little more of a bounce. I think by constricting the rotation, we're actually limiting the bounce a little bit. So I'm going to turn these off so we're no longer restricting the rotation. And let's just see what happens.
Also, I think maybe if you set the cubes back to the flat, it would help. Because right now it's not hitting it head on. It's losing a lot of the energy sliding. So it's not really full back. That's
definitely a good call. So we can set these rotations back. And we can also try one more thing after this. So let's see how this bounce goes. All right, that's a little bit more of a bounce. And I think if we go and mess with other physical properties, like setting the mass of this cube higher, that might also make the bounce higher, because then it's a heavier version of itself. Maybe not. But you can play with this. There's tons of settings, and the important ones are all either on the rigid body for the object, or in the physics material for the box, your collider. And you can set up all sorts of shapes. Like we don't have to just do cubes. We can add like a sphere into the middle of this. or that cylinder I was playing with before. So like 0, 0, 0, 5. Yeah, so now if I add a rigid body to this, and typing it in quickly because you had a lot of rigid bodies, and we let this play out. That's pretty funny looking.
That was pretty cool.
Let's see. And so this is an interesting thing. So this balances perfectly. So I assume eventually this will start to rotate or it'll start to fall because a sphere, I mean, maybe it can sit perfectly. Let's just
sit here and watch it for a while.
Yeah, it is pretty fun to just play with this and mess around with all these things that interact. But you know, this doesn't really make a game, right? Like these are all fun for us, like playing in here, but this doesn't, you know, end up with a game. So I wanna start another project where I have some art assets and some things like that, and we can actually like put something on the screen that isn't just shapes. And we can mess around with that and look at like what does making something that's actually moving and like looks like something feels like in Unity.
Actually, I have another question. If you wanted to make water, how would you? You'd make another material, but water would be like it would separate into different. If you had a cube, for example, it would separate into 2 streams.
Yep. So
how would you do that?
Water is a very, very interesting question.
I don't know if you're going to make it through your demo with all these questions, but I love this panel.
No, it's fantastic. The questions are what we're here for. And so I haven't actually done water in Unity, so I don't know offhand exactly how it's done. However, in general, I'll tell you that it's not going to be a normal box collider, rigid body. Like you're not going to get a cube or a cylinder and say turn this into water. You're going to go into like your 3D objects, and I think it might be a type of terrain. I'm not actually sure. And you can like go into here and set up water. Yeah, so there's like options. I don't know this well enough to tell you exactly, but the short answer is it's something completely separate. And it used to be that the paid version of Unity, one of the big differences was that it included the ability to do water stuff, because water is such a complicated, like technical and important part to many games that they're like, that is what you have to pay for. I don't know if that is still true, but yeah, it's kind of a whole other thing.
Water actually is a really difficult thing to do because the developer has to decide whether they want it to be one body water or if they want to program in 1,000 little particles for each drop. And like there have been games that have gotten praise just because they did so well with water, because it's a really difficult thing to get the hang of.
Sounds difficult.
It absolutely, it absolutely is difficult and very specific to games. Like depending on what you want your water to do, you got to go completely different routes to do it. So it's
kids are flying right past the beginner stuff, huh?
How do we simulate a mountain streams? Yes.
There's a question in the chat, and I think I answered it, but I could be wrong. JavaScript and C# are the 2 languages that you need to use, right?
Technically, yes. However, it is highly recommended that you use C#, not Unity. I mean, not JavaScript.
This group is JavaScript developers, right?
Oh, yeah,
so one person asked if JavaScript was available.
So here's the problem, though. It's not real JavaScript. So if you are a real JavaScript developer, you will get infuriatingly mad trying to write Unity's JavaScript, because it is not JavaScript. It is a Unity script, and there's a whole bunch of craziness. Like you can go try, but like if you make an object and then try to tack on a property to that object, it can't handle that. Like it is really, really stupid. And it's already like they used to support 3 languages, another one called Boo that no one's ever heard of. And then they've just completely given up on that. And so now they just have JavaScript and C#. But I would suspect they'll drop the JavaScript support soonish. And C# is clearly what they're betting behind. And it's not a very hard language. So I would recommend doing that. Like to get started, JavaScript is fine, but you'll find it very, very maddening, as I did.
Okay, thank you.
All right. Good question.
Cool.
That was from Arthur in the chat. Thanks, Arthur.
Yes.
Lovely question. All right. Any final things with our cubes or with our circles? Any other thoughts? Anything else related to this that anyone wants to know?
Well, I don't know how you're going to top this. I mean, your next demo, I don't know, man.
So the next demo has pretty pictures, and the pretty pictures really help sell these things. So let's hop over to a new project. So I'm going to go open project, and we're going to go over to my Unimoji project, and we'll save the scene. Why not? It's a great scene. It would take me forever to put those cubes back. I definitely want to save that. So this project is basically an empty project with the exception of the fact that I've imported about 1,200 different emoji. So I have a bunch of cute images to play with, and we can do some cool stuff with that.
I'm so excited.
Right. The one other difference is that this is going to be mostly 2D. I'll show you a little bit about how 2D and 3D things work in Unity, but since emoji are 2D, it makes a lot more sense to do something 2D with that. But I want to build up something that actually looks like a game. Like I want to build something that like you would look at and you would think that is not cubes. Like that is a real thing. So let's do that. You see, I have down in my assets folder 4 things. The snow we can ignore for now. I'll show that later. But we have a ground image. And if we click on this, let's see, it'll pop up. Yeah, there you go. It's just a normal like image, could be drawn in like Photoshop, could be drawn in free software like GIMP. You have a million options. This is actually an asset from a game I built for Google I/O, but you know, these can be anywhere. You can download them. Sam was asking earlier about where can you get art to build a game with, and there's a bunch of great resources online. There's like sites that just have dedicated free game art. And another option is the asset store. So if you go to Window and you find asset store in here, and then that'll make an asset store tab. This is like a collection of some free and some paid Unity assets. So if you wanted, for example, like AK-47, you search for that, you'll find a 3D model of an AK-47 for $6. And there's also free ones, and there's all sorts of different stuff in here.
Are there kittens?
I
Inquiring
100%
Sam wants to know.
Let's see the kittens.
guarantee. Yeah, there you go. Cute kitten 3D model.
Aww.
This is free, of course. So that's kind of creepy.
Can you
actually.
fit that in your game?
Hey.
I
know we're hijacking everything
No,
tonight.
that's all right. We're going to download this and see what happens.
Yeah.
All right. I have no idea what's going to be in here. Let's see. So this
Now
contains...
you've officially sold Samantha on Unity.
Oh yeah.
Oh,
yeah.
man. This has got animations and all sorts of cool stuff in here. Yeah, so we'll see. We'll see how this goes.
What's Angular?
Oh,
This
come
one's
on.
got kittens.
All right, now that's a little much there.
So in terms
Remember,
of
we're
3D,
an Angular meetup. Don't steal
Hey,
all
he's
our
got
people.
kittens.
Yeah,
We're gonna have
that
to
is pretty cute.
Kittens and AK-47s.
like all the best video games.
Right.
A winning combination.
No, kittens using AK-47s.
What were
There
you
we
saying,
go.
Alex?
Yeah, that would be a
All
perfect match.
I said we're gonna have to worry about a lawsuit from Leslie 3D
Yeah.
stealing their kittens.
All right. So one of the things I noted in the beginning was that there's not any difference between a 3D and 2D Unity project. It just kind of changes how your editor looks. So right now you can see this is a 2D view. It shows like exactly what I'm going to be seeing on here. But if I hit this 2D to 3D button up here, it just turns it into a 3D plane. So now I can go and like deal with those assets we just got in that kitten package in the 3D environment. However, they'll still be rendered flat 2D over in the game, but that's fine. So let's see what we can do here. Let's see what we have in this kitten package. We have some prefabs. Let's just drag a kitten into the world. There it is.
Yeah. Music to my ears.
Let's move this closer. Is that a very, very small kitten? Perfect.
There's a kitten's butt.
There you go. There's our kitten. So this has like a bunch of different things, right? Like we covered like a rigid body and a collider, but there are tons of different stuff in this object I just added to the scene. It's got like a camera controller. It's got animation on it. So I have no idea what this is going to do when I hit play, but let's just see what happens. So it takes a second, and our kitten falls to the ground.
No.
Let me go
There
ahead
went the kitten.
and let me add some ground for him. We'll add a game object, 3D, cube.
Would
We'll
turning
make
this
this
back be faster?
It could be, but I also think it might interfere with some of the scripts on the kitten, and I want him to be able to like walk as she likes. So let me do that, and let me also change this camera to perspective. So now this is exactly the same as if you were dealing with a 3D game. I just changed the way the camera works now, but that's not important. All right, so let's see what happens. We hit this. Okay, so this is a first-person kitten. So it took control of my camera, and it's now automatically moving it to follow the kitten around. And yep, I can walk around with that.
Is the tail moving?
She's stuck in. Tail
Oh
is
yeah,
moving.
it's wagging its tail.
She's stuck in the ground though, which implies to me that her collider is a little too high. So let's go here, click on our kitten. Oh, and you see these green lines, just like we saw before. This is what's keeping her from falling in the ground. But for some reason, that's at about, thigh level. So let's go over here, look for our collider, which is called character controller here, and see if we can move that down. Yeah, that's too low. Mine is 0.1, no? 0.1, 0.12, something like that. That looks like it lines up with her feet a little better. See, there you go. Now she stands on the ground better.
Abe saving the day.
Can I get
Abe
her?
is great.
Abe is great.
So now this
Saves my
kitten very, very slowly walks around with a camera for some reason in her butt. But that might be why the collider was higher, because the camera was tied to the position of that collider. So when I moved it down, it moved the camera down. But we can see over in the scene view, this kitten is very, very slowly chilling around.
This is actually a really good, it's called environment. So how would you change the camera to do a first-person view?
Butt, Abe.
Let's see. So you see on here, we have like some built-in components on this kitten game object. We have this animation controller, which is built into Unity. We have the character controller, which is built into Unity. And then we have two other scripts. We have third-person camera and third-person controller. And you notice how these have this little JS name right by them? That shows me that these are big files of code. And I have no idea what's in these. I guarantee they'll be complex. So I can double-click on this, and it'll open up my editor. And yeah, look at this JavaScript, folks. Look at this. That definitely looks like JavaScript with your private variables. This is the craziness of Unity script right here. So in here somewhere is the logic that says like where the camera fits and how it moves. I don't have the ability to just like eyeball this and change it to be first person. But because of the way Unity works, and when you go download an asset package, if it has code in it, that code's always going to be available to you. So it's the same as downloading like a complete open source example of how to move or how to interact with the world. So you can go and start reading this and trying to find out, what's happening and disabling and enabling different things. So somewhere in here is the stuff that would allow us to change how the camera works, but it's not going to be something.
And another thing, probably if you download, say, a kitten that just is kind of weird and just doesn't seem to be working the way you want it to, you could probably go back and find a lot more kittens.
Yes,
I know sometimes with like content management systems, plugins and templates and stuff like that. If there's one that's it's got that JavaScript and it's just weird, it's usually especially if you're not real familiar with JavaScript, you could probably go back and find a different one.
Yeah, you can see these much more realistic cats in here if you want to find other cats. But yeah, there's no shortage of cats.
Yeah.
So you have tons of options, and so if you want to, this is a cute kitten pack for $10. Maybe we should buy. Oh, they are cute. Okay, so yeah, you can go find all sorts of different stuff in here. You can just find that. But not only can you find assets in here, but you can find like extensions to Unity, things that are like IDE plugins for doing different things. There's a bunch of really popular ones, so we can just go here and like look at like most popular. So this is a visual programming language for Unity, I believe, so that you don't have to write code. You can like drag and connect things if you don't actually want to write code. That's $65. You can go and see like different shaders. The Ultimate FPS Kit, which is like all the scripts you need to like put together a first-person shooter, and you can pay a little bit of money and download these. And then there's also a bunch of free ones to explore. And they have demos on their site of like, here's a complete game that you can just download and play with. I'm trying to remember what any of the names of those are, but it's like there's a bunch. You can go check them out. But this is a great resource to know about, to just find things you want, get temporary art for your game, or real art. And if you play enough games and hang out in the Unity Assets Store enough, you'll see actual games that have bought assets from here, and you'll be like, oh, that's where that art came from. They paid for it in this asset pack. They paid $20 for it. So it's super cool. But yeah, there's tons and tons of cool stuff in there. Sea life back. We could get some manatees in here. Sure. Anyway, yeah. So I'm gonna try and focus here for a second. I love the kitten, but we're gonna get rid of the kitten for a second, and we're gonna try and focus on building something from scratch. All right. So let's go and set this back. So I'm just setting everything back to how it was when it was 2D. So it goes back to like a little 2D game. So I want to just go and use some basic images, like in the simplest possible way, to put something together so you understand like how to get art into the game that you haven't downloaded from the asset store, because that's pretty much the first core component to making something cool in Unity is getting some cool art in it. So if I have, like I said before, this image that is just like some ground, all I have to do to get that into the game is just take that PNG and drag it over here. You can see it immediately shows up. I just put it somewhere, and there you go. We now have a ground. It's a little big, so I think I'll actually scale it down a little bit. So put like 0.5. Then I'll change my positioning handles. There you go. Now, like my background blue, like this sky blue, is a little. It's like too blue. It kind of meshes with that green wave. So I'm going to go to the main camera. I'll go over to the camera in the inspector and look at the background. Click this, and I'll change this to like a lighter, maybe like a very light blue, so it's a little more clear. And there's a whole bunch of other camera properties on here you can play with that do different types of rendering. You can resize the camera, so if you wanted it to be bigger or smaller or whatever, that's all your camera properties are just on this main camera object. So I'll quickly take that ground. I'm going to add a collider to it. And remember, when we created those cubes, we just said, hey, like make me a cube. And it came with the box collider, and we added the rigid body to physics. But if we want something to interact with this ground, we need to go add these things by hand. So right now, the only thing on here is a sprite renderer that says, hey, draw this image, and that's it. So let's add on a box collider. And this time we're doing 2D stuff. So we'll go to a box collider 2D. And you can see we get those green lines, just like before. And since this is ground, we don't want all this space in the image to be collided with. So we're just going to change the size of this. Nope, that was right the first time. Add it like 3, and then move it down a little bit. So now you can see that the green line for that cube, or for that box, is about equal with the grass line. Like it's close enough. And we don't need a rigid body on the ground because it's not going to be falling or moving. So we're good there. And then I want to just add in something to fall on the ground. So we're basically creating the same environment we had before. We'll add in this case, a billiards ball out of my amazing pack of every Android emoji ever. And this ball, just like the sphere and the cube before, it'll need a collider. So we'll get a circle collider this time. The box collider, the square collider, any of those, they're great for those shapes, but this is a circle. So we'll add a circle collider 2D. And you can see it picks up on how big the circle is. So it gets that green line to say, all right, physics are happening there, and it's exactly the size we expect. And because we want this ball to fall, we'll add on a rigid body 2D. Now everything's set up. If we hit play, that billiards ball should fall to the ground, boop, as we expect. Nothing horribly interesting, but we're back basically in the same spot we have before. So now if we go a little bit farther, if you're building an actual game, your art is not all going to be squares and circles. It gets more complicated than that. So imagine I add in a football. If we want physics to happen on a football, how would we possibly do that? If we go and we add like a box collider to this, well, look, it's square. That's not the shape of the football. And so that's not it. So if we move that, let's try like a circle collider. Well, that's closer, but that's still not really the shape of a football. So if we hit play, if we add the rigid body, we hit play, it's gonna fall, and it looks okay, but we know that there is extra stuff there. So now let's try one different type of collider, and this is the coolest one. And this is a polygon collider. And polygons, if you are not to the point in school where you know what a polygon is, that just is like any shape. Like any shape is a polygon. So when we're adding on a polygon collider, that's basically saying match any shape that my art is, make that the collider. So if we say polygon collider 2D, it magically looks at that football and creates a very unique shape that matches the football as closely as it can. So
My mind is
now,
blown.
That's
right?
pretty cool. And does that automatically? You didn't
Yeah.
even have to like adjust it or anything. It just knew the shape.
Yep, it just looked at the image and said, hey, this is where the image is. You probably want this shape collider. So now if we hit play,
That's awesome.
that'll fall and it'll roll just like a real football.
Oh, wow.
Yep.
Hey!
Because along with adding that collider, it also understands balance and mass and everything like that. So it's picking up on that and making it act like a real object.
Shouldn't the circle have done that too then?
And well, I mean, a circle in theory is a perfectly round object. So it wouldn't move unless some external force applied to it. So if we
I had
move,
circle things, I would drop it, and I feel like it would roll.
yeah, but that's because there's outside influences, right? Like the ground isn't perfectly level. You didn't drop it perfectly flat. But if we add in a little bit of movement, so for example, if the 8-ball falls on the football, it will start rolling. It'll start moving how you expect. See, there it goes.
Okay.
Because it hit
And it went
that,
off the
so it
roll.
has some, and it falls and goes away forever. Unless I ever destroy that, it's just going to continue existing. But you see, the football wobbles. Everything is happening, about how we'd expect, because Unity is smart enough to wrap these objects, in the right shape. So another interesting concept here is that, remember, not everything on the scene has to be interacted with. So if I wanted to put something into my scene, so I'm a big fan of my own name, so I'll just type out Abe. This is completely unrelated to physics. I haven't done anything. There's no colliders. Those letters are just there floating in the scene. So if you had alerts that were popping up, or like I said, a health bar or things like that, you wouldn't want rigid bodies. You wouldn't even want colliders on them, because you want what's happening behind it to be the actual physics environment. These words have nothing to do with it. So we'll get rid of this. We don't actually, or I can make it small and put it in a corner. 0.2, 0.2. Okay, perfect. All right, now it says Abe up in the corner. Okay, perfect. So now we have some elements that are interacting with physics, some aren't, some are round. There's one other part that I want to do. I want to add some movement to this, because so far everything we've been doing, we've been looking at how they work together. We're never influencing the scene. We hit play, things fall, it looks cool. But what if we really wanted to control something? We wanted to write some code to influence what was going on. So I'm gonna move this 8-ball back over here so it doesn't do anything. And then I'm gonna go and I'm gonna find something in my amazing pack of assets to animate in the scene. So that's bicycle. Bicycle seems good. So we have a bicycle. It's a little small. Move like 2-2. And we'll do the same thing. So I'll add a rigid body 2D. We'll add on that polygon collider. And it'll be super smart. So it'll look basically like a bicycle. And now if we hit play, that bicycle will fall just like everything else. And we're all good. But I want that bicycle to move. I want it to be a ghost bicycle that drives its way around. So I'm going to move this so I have a little more space to set the bicycle. And I'm going to go add some code to this bicycle so that it does some driving for me. To do that, I'll go over here. I'll click on that object, go over to the inspector, go down here to add component. And I'm just going to make a completely made up name. I'll call it like drive left. It'll ask me, do I want to make a new script? Because it couldn't find it. This isn't like rigid body that already exists. I'll say, yes, I want a new script. In this case, I'll do it in C#. That's what Unity games should really be done in. Don't worry, it'll be a very small amount of C#. And then I double click on this and it'll pop up in my editor. You'll also see that now the drive left script is set up right over here in my assets panel. So I can take this script, I can put it onto other objects, I can reuse it. But in this case, it's just attached to my bicycle. I'll go here, I double click, so it's created this drive left.cs. I'm gonna do just a couple of things so that I can control this bicycle in a very minor way. I'm gonna say I want to public vector3 and call that direction. Now when I save this, Unity is smart enough to say, all right, you've declared a public variable. In other words, you've set up this direction that has an X, Y, and Z. And if we head back over to our editor and look at our bicycle, our drive left script now has a direction property. So we can now customize what this drive left script does. It might not actually drive left since the direction is now customizable. And then we'll add a public float, so just a public number called force. And after it gives a second to recompile, that force will also pop up here. So now we can control what direction and what is the force being applied. Then lastly, in a fixed update, so this is what's called every frame. Is everyone familiar with the concept of like frames per second in video games? Is that something people understand?
Yeah, everyone's nodding.
Yeah, okay. Yeah, I can't see anything, so.
Okay.
Yeah, the idea is if something is running in the update loop, that just means call this code every frame. So if your game's running at 30 frames per second, it'll be called 30 times. 60 frames per second, it'll be called 60 times. This is very different.
But you changed the name of that function.
Yeah, I did. And the reason is if you're doing something that is like manipulating the game, you want it to be in the update function. But if you're doing something related to physics, which I am, you want it to be in the fixed update, which helps with that, like making it play out the exact same way every time.
Gotcha.
Because if I start dealing with physics in the update method, it'll impact, like depending on the frame rate the game's running at, it'll change it. But if it's in fixed update, it'll always be exactly the same.
And this is C#. So if the kids want to learn a little bit more about how to do the actions and stuff, then they should maybe pick up a book on C#.
Yeah, I would recommend it because the mutated version of JavaScript that it uses is like not useful as JavaScript. So yeah, learning a little C# would be very helpful here. But really, you'll find it's not like C# specific in general. It's like general programming concepts. A lot of the code that people write in JavaScript for Unity can be copy and pasted into C# because their weird version of JavaScript looks a lot like C#. Yeah.
Sorry.
Go ahead, Sam.
The tutorial for the rollerball that me and Nicholas did, we were writing C# and we did write a little bit, and he explained it really well. So maybe I can I'll tweet a link to the tutorial we watched, and you can retweet it, Mom. But it was really good, and it did explain all the code that we had to write in C#, which we did. It was cool.
Yeah, and they didn't know any C# when they started, so it seemed to be a pretty good explanation.
It's a pretty reasonable language. It's nothing too crazy. So if you have some JavaScript experience, you'll see a lot of similarities. The big things is like you have to declare what type of variable is. So we know this is going to be a number. So we're not just saying var force equals something. We're actually saying this is a float, which is like 7.2 or 8.9 or something like that. So there's slight differences, but in general, it's not that big a deal. So in order to make this work, there's one last kind of confusing bit we have to do, which is that we want to apply this force to this bicycle to the rigid body 2D. We want to push on that rigid body. And in this script, we don't have any access to that rigid body. So we actually have to fetch it. So we'll say, this isn't going to be public. This will be a rigid body 2D, and we'll just call it RB. And now this is just an instance of rigid body 2D. So in our code, we'll now have access to all of these things, all these settings. So we'd be able to change in our code the drag, if it's using gravity, the mass, all of these things, because this is just another script, and we're just importing that to access it with code.
And you don't have to identify which character or which item it is on your stage, because this script is only for this particular bicycle.
Exactly. Yep. It's attached to the script. So we do have to write one more line of code to actually get the instance of this, but because of how scripts are working together, it knows I am on this parent object. So there's not anything like looking up the bicycle object to like pull in that specific rigid body. It's like traits on the same object. So if we go back to our start, and this isn't horribly important to understand, I'm going to call get component and pass in the name rigid body 2D. So all this is doing is saying this rigid body is now set to the instance of the rigid body on my bicycle. It's not any other one. It's not nothing. It is the rigid body that is in the same inspector as my drive left script. Now in our fixed update, we'll say rb.add force. So this is just a method on the rigid body 2D that expects me to apply a force. And it's actually expecting a vector too, because this is a 2D. So it's just x and y. And we'll say push in direction. That's it. That's all I'm going to do. And we'll see what happens here. We'll ignore the force variable for now. We might actually not use it. But all we're doing is setting a direction that is like up, down, left, right in our code with those x, y values. And then on a loop, applying that force to our rigid body. So let's hit play. Now that we've written some code, we're going to want to keep an eye on next to the project. We have a console tab. If we have any errors or compiler issues, they'll be in this console tab. Now we have our bicycle. Let's see if we can apply some force to it. So in theory, if I apply a force of like 100, yep, my bicycle just shot way up into the air and it's still flying, and eventually physics will get to it and it'll fall back down. But what I did there, yeah, there it is. And back it comes. So all I did there was I started with a script that had no direction set for that force. There you go. And as soon as I typed a number in here, it started applying that force. If I can get the bike to like hover, let's see. There you go. Nope, too much. You can see how this force is just getting applied. And it's, again, shooting my bicycle way up. So if we want this to push left, we want it to clear off everything on our screen. Let's try setting an X of like 20. And remember, this force is like a physical force pushing on the bike. So it's the same as like pushing an object across the table. It has to overcome the friction of sitting on the ground. It has to overcome the mass of the objects it's going to hit. So I'm not sure what this number needs to be, but it needs to be enough to overcome all those things. So there's a really good chance I'm about to hit play and nothing will happen. And notice how before I was editing these numbers while the game was running to play with it. But now I'm not running anymore. I don't have the play button checked. And I'll go and say, set the direction of X to 20, and let's just see what happens. Okay, that was the wrong direction. My bicycle just flew way far away. So let's try this. It's got to be an X of minus 20. Let's see what happens. There you go. My bike drives across the screen and drives off into the distance.
Yeehaw.
Yeah, there's one big issue with this though, which is that obviously the bike is missing the balls. Like it's supposed to hit those. I need to delay what's happening here just a little bit. And this is going to take a little more C# logic, and this will probably be the last bit of code we get into. So if this is very confusing, don't worry, we're not going to dive much more into it. But we just need to delay the movement of this bike just long enough so these balls can fall and it can hit them. So we'll go, I'm not going to use this force variable, so we'll just change this to delay. And then we will make a new Boolean variable, so true or false, and say is active. That'll default to false. And we'll make an I enumerator. It's not important to understand what this does here, what an I enumerator is or anything. Like all that's important is that this is an object that can take I enumerator.
And I know we're running short on time, but they can also Google that I enumerator and all anything that they see you type it in here that they don't understand. Probably they could find, especially if they Google Unity and then that whatever that tag was.
You don't even have to Google it.
Oh yeah. That's one of the great things I forgot to mention. If there's anything confusing, as Sam has informed me, there's a keystroke, which is what to get info.
For a Mac, it's command and the single tick quote
apostrophe.
Mark. Yeah, and for any other computer, I think it's control.
Yeah.
Maybe?
And then you can also look for these little icons here. So if I wanted to know more about rigid body 2D, I can click on this little book here, and it will pull up the Unity documentation for the rigid body 2D. And it'll explain how they work and all these things. And one important thing is that this is for people who are just looking at it in the inspector. But if you hit switch to scripting, it'll change to the programmatic reference to a rigid body. So anything you want to do related to programming, changing properties, adding a force like we did, we can go here and say, all right, here's rigid body 2D add force. That's the method we called. Here's what that takes. It's all right here in the documentation.
The documentation
I
is
think,
really cool.
yeah, documentation is really good. So I'm going to wrap up. I'm actually going to skip. For some reason, it's not letting me delay this, but it's a little bit too much in the C# anyway, so it's fine. I want to show you one last thing that was going way back to what Alex was talking about predictability. And I want to show you an actual game I wrote in Unity, built using, all the things we talked about today, which is this game called AppShip 3000. And this was something we built for Google I/O this year. And it's a collaborative game where you answer trivia questions about Google Cloud and Firebase and all of these things. But there's something particularly interesting about this game that I can show you. So this is the entire game loaded up. The way this game works is that there's 3 different screens at any time with 3 different people playing it, all working together to fly the same rocket ship. And you can see we have this big setup where we have, like over here, a rocket ship, and different UI parts all kind of set on top of each other. We have 3 different setups of the screen that are then rendered out to different monitors. It's a pretty cool setup. But what I really want to show you guys is the game over scene. So if I hit play right now, all of this stuff will come to life over in my scene view, and we get to an enter a launch code screen. Rocket's just sitting there. I won't go through the whole launch code sequence, but I'll turn off the tutorial and the launch code just to show you guys what the gameplay looks like. And these are all custom things I've written. Like, these are all public properties on my scripts that are showing up, so I can configure all of these things to do all sorts of stuff. But I'm just turning off the tutorial and the launch code. My rocket ship takes off, and it starts getting Firebase trivia questions, which I will not have the ability to answer. But this is the general idea of the game. You get questions, you answer them, your rocket keeps flying. To get to the end game sequence, I'm actually going to hit this handy button I have called fast forward that I programmed in that makes you die really quick. So you'll see I have my fuel down here. It depletes really, really fast. And then my rocket starts sputtering, and it falls out of the air. So this end sequence right here is what Alex was talking about, where he's like, if you can perfect the physics, if you know they're going to go the exact same way every time, you can animate something, or you can set up a world that it'll play out in the exact same way. And that's exactly what I did here. I just paused my game by hitting the pause button up here. But as soon as I hit play, you'll see the physics-based end sequence that is the exact same thing that gets shown every single time this game gets played, because the physics happen in the exact same way. So I unpause, my rocket falls from the air, does exactly 1 flip, and then from the side, a bulldozer comes and pushes it away. And that's just set up with some physics and some timing, like same type of script, and then the thing falls away there. Exactly like the scene we just set up. Some physics properties on the rocket and some forces applied to the bulldozer, and we end up with that end game. And because it's exactly the same every time, it can be very consistent and always look cool. So I think that's about all I have time for. I know we got sidetracked a lot, covered a lot of random stuff, but hopefully this at least piqued your interest in Unity as a game engine. It's really, really fun, and it's pretty easy to pick up if you know some programming, and even if you don't, there's a ton of great tutorials. Sam is going to link some, like she said, but there's also these great video series Unity puts out that are like 12 parts how to make a very specific game, and they walk you through every single part of it. They walk you through all the Unity concepts using all the different parts that we didn't talk about, and they're really great. And those are all just on Unity's website that you can go check out.
Yeah, that's what me and Nicholas watched. One of those series.
Yeah.
Yeah, it's absolutely awesome.
This has been such a cool demo. I love this.
Yes, this is really awesome.
And we had a really good panel tonight, guys. Y'all asked some very good questions. This was pretty cool. So I have a question for you, Abe. I know we're out of time, but if these kids run and download this and play around with it and have questions, because I think I have a feeling this is probably going to be pretty popular. I know my group is Angular and this is not Angular, but this is so cool. If they come back with some questions and start doing this, would you consider coming back to visit us again with the same panel after like a month or 2?
Oh yeah, absolutely.
Because this was really fun.
Yeah, no, I'd love to see what you guys made. Like that'd be awesome to see some like little things put together that you're making progress on. Any questions or anything, I'm always happy to help with. Cool.
So Nicholas, Alex, Sam, if you guys want to go and make a game and come back, if you guys have questions or you get stuck or you want to talk about it, then just ping me, let me know, and we'll get Abe to come back and visit us again, because this has been a lot of fun.
Even if we don't
Yeah.
like make up any questions, he should still come back because this was like really, really cool. To show it's more, let's do dogs next time.
That's your job. Well,
Yeah, you just gotta come and hang out with us once in a while, Abe, because you're fun.
Yeah.
Yeah, it's been super awesome. I will say that one thing I noticed earlier, Sam was asking for someone who asking for art assets, and Alex was saying he only did the art. So I feel like there's some chance for some really awesome collaboration here that could produce something really, really cool looking. So just saying, I have high expectations of all of you.
Yikes.
Okay, so don't forget, you guys can find unity3d.com is this platform, and it's open source. So go get it, download it, and there are so many resources. There's tutorials and assets available on the Unity site. Then there's also Unity3D on Twitter. And you can remember Abe's Twitter handle because Abe is great is Abe's Twitter handle. And Abe actually is great. So it's super easy to remember. So guys, do you have any questions for Abe before we go?
Well,
No.
the question that I asked right before we started about if you have to go through the App Store or whatever, I think that would be a good to tell everybody who's watching the live stream. That would probably be a question that they might be wondering. If you make an app, do you have to go through the App Store or the game store or whatever?
Yeah, and the answer is yes. Unity builds out to native iOS, native Android, web, a bunch of other game platforms. In fact, it can build out on PS3, Xbox, all these things. But they're all like native builds for those platforms. So if you want to ship an iOS app, you have to go through the normal iOS launch process. If you want to ship an Android app, same thing. It's always the regular formal process. Obviously, if you want to just send something around to friends, it's easier. But if you actually want to distribute it, you have to do the real thing.
Okay.
That's awesome. Nick, did you have a question?
No, not really.
Okay.
He explained everything really well, actually.
Yeah, this is
That
pretty
was
cool.
awesome, Abe.
So I'm glad you liked it.
If you guys love video games, you can actually use this and you turn your video games into like making money and paying bills, which is
And
awesome.
I should,
And if you don't like video games,
yeah, if you don't, then program in something else. I will say though, if you're interested in building not just like local games like we're talking about here, there is a cool cloud service called Firebase that happens to have great Unity integration. And if you want to see more of me, there happens to be a handful of YouTube videos about me talking more about Unity, specifically with Firebase. But if you're interested in making like multiplayer games or online games or anything like that, the Firebase Unity integration is a great place to start. But you can still make a ton of cool stuff without that. It's totally extra, just if you want to make connected online games and such.
So like multiplayer, you can like play with your friends?
Yep, stuff like that. Or even just like having push notifications in your game when somebody invites a friend, or dealing with like signing in with Twitter to sign into your game, or uploading images or anything like that. All these things that you would normally need servers for. Firebase
Just
helps
whatever
out
you
with.
do, don't make a game with push notifications every day that say, you haven't played in a while, come back, because people will delete your game.
But
oh
it's
my
super
goodness,
annoying.
I can attest.
Yeah, that's
Yeah,
very
so don't do
important.
that.
Alex, do you have any questions?
I've got about 1 million questions, but I feel confident that I can figure them out now. Cool.
That's the ideal space to be in.
Awesome. Well, I guess we're going to call it a night. This was so much fun. And I think this was probably, even though it's not even Angular and we're an Angular meetup, this was still probably one of my favorite sessions, because this was a lot of fun. And Abe, you are great. And you're welcome to come back anytime. And kids, when you guys go and make your games, if you get stuck, or if you want to come back and hang out with Abe again, let us know, and we'll set it up, because this was a lot of fun. And really, I got to give a hand to this really cool panel, because you guys asked some really good questions tonight. So thank you very much. Thank you, Abe, and thank you, everybody.
Awesome. Thanks for having me.
Thank you.
It's been awesome.
It was fun. All right. Thanks, everybody. Have a good night.
Bye.